Hey everyone, and welcome. From the very first humans who looked up at the night sky to the rockets we send up today, our need to explore what's out there, it's one of the oldest and honestly most inspiring parts of our story. So let's dive into this incredible journey together.
I mean, have you ever just gone outside on a really clear night and just looked up? That feeling you get, that sense of awe, and all the questions that start popping into your head, well, that's exactly where this all starts. It's a kind of curiosity that connects all of us across thousands and thousands of years.
And really, at its heart, space exploration is just our attempt to answer those big questions. It is the ultimate quest driven by this deep need we have to figure out our place in the universe. And as we're about to see, it also helps us understand our own world a whole lot better too.
Now, you might think this is all a pretty modern thing, right? Rockets, satellites. But this quest, it's not new at all. Long before we had any of that, the sharpest minds traveled to the stars using math. And believe me, ancient India was a major hub for this kind of early cosmic mapping.
And this was way more than just casual stargazing. Through what we now call Indian Knowledge Systems, or IKS, which is basically this amazing framework that combines math, philosophy, and really precise observation, ancient astronomers created incredibly detailed records. They built calendars, they predicted eclipses, and they made sure all that knowledge was passed down for generations.
And right at the forefront of all this was an absolutely brilliant astronomer and mathematician named Aryabhata. Now this is where it gets really mind-blowing, because the ideas this guy had were just so far ahead of his time.
Just think about this for a second. We're talking over 1,500 years ago, at a time when most of the world was absolutely convinced that the sun went around the Earth. Aryabhata proposed that, no, it was our planet itself that spins on an axis, and that's what creates day and night. It's a concept that is totally fundamental to modern science, and it was confirmed centuries later. Just incredible.
And he didn't stop there, not by a long shot. He took on old myths, explaining eclipses not with gods but with pure science, shadows and geometry. He figured out the positions of planets with really impressive accuracy. So the main takeaway here is that this was a revolutionary shift towards a scientific way of thinking, based on hard evidence and mathematics.
But this super rigorous approach wasn't just limited to one person. Another cornerstone of this whole tradition is an ancient text called the Surya Siddhanta, and it built on these ideas in some truly remarkable ways.
You can think of the Surya Siddhanta as a kind of comprehensive guide to astronomy. It wasn't just observations. It laid out the mathematical tools you needed to calculate everything from how long a year is to the exact timing of an eclipse. It just brilliantly shows this deep, systematic understanding of how the cosmos worked.
Okay, so if the mathematical foundation was laid out so long ago, what changed? What was the missing piece that lets us not just look at space, but to actually go there? Well, the answer is all in our modern toolkit.
So how do you make that massive leap from theory on a page to physical exploration? Well, it takes a whole new set of tools, ones built specifically for the stars. First up, you've got satellites. You can think of them as our robotic eyes, our ears, and our messengers, constantly orbiting the Earth and flying out into deep space, sending back data for everything from your phone's GPS to images of distant galaxies.
Next, you obviously need a way to get all that stuff up there. That's where rockets come in. They are the incredibly powerful engines that let us break free from Earth's gravity and launch everything, satellites, probes, and yep, people, out into space.
And once we're up there, we need a place to stay and work for a while, right? That's what space stations are for. They're basically our laboratories in orbit, where humans can do long-term research in microgravity, pushing the absolute boundaries of science.
And this is where that ancient legacy connects right into the present day. That same spirit of astronomical curiosity is totally alive and well, but now it's powered by modern tech, and it's all on display in India's amazing space program.
The Indian Space Research Organization, or ISRO, has become a real heavyweight on the world stage. It's taken all of that foundational knowledge and just launched it into the 21st century with missions that are not only groundbreaking, but also unbelievably efficient.
I mean, just look at some of these highlights. You've got the Chandrayaan missions to the moon, which have given us so much priceless scientific data. Then there was the Mangalyaan mission to Mars, a total stunning success that was done for a fraction of what other similar missions cost. And now, the Gaganyaan program is getting ready to send Indian astronauts into orbit. It's a really exciting time.
But you might be thinking, okay, that's all really cool, but what does any of this actually have to do with me?
Well, it turns out that the technology developed for these massive missions has a surprisingly huge impact on our day-to-day lives.
You see, every single time we aim for the stars, we end up inventing things that make life better right here on Earth. The tough challenges of space force us to come up with brand new solutions, and those solutions have a way of finding their way back into our homes, our cars, and right into our pockets.
Seriously, think about it. The GPS on your phone that helps you navigate through traffic, that's all powered by satellites. Those accurate weather forecasts that warn you a big storm is coming, that's satellite data. Global communication, helping out during disasters, all of it depends on the infrastructure we've built in space.
So as we start to wrap this up, it's pretty clear that this isn't two different stories, an ancient one and a modern one. Nope, it is one continuous, unbroken journey of human curiosity.
What we're really seeing today is this powerful synthesis. It's the fusion of ancient wisdom and observation with the power and precision of modern engineering. Each one builds on the other. It's like the ancient blueprint is meeting the modern rocket.
And that, right there, is the path forward. The spirit of Aryabhata is alive and well in the control rooms at ISRO. The mathematical genius of the Surya Siddhanta is echoed in the complex orbital mechanics that guide our spacecraft today.
So it all leaves us with one last, really exciting thought. This unbroken chain of curiosity has brought us all the way here. As we keep pushing even further out, to Mars and who knows where else, what are the timeless, fundamental questions about our universe and about ourselves that we will finally be able to answer? The journey, for sure, continues.